All right, so this is diving into these evidence-based practices and some of the high leverage practices. Some of my experiences, I've worked at the elementary, I've developed some early numeracy interventions, but most recently, I am one of the PIs of a model demonstration OSEP funded grant. There's 3 of us that won. One thing we're all trying to do is how do we increase algebra readiness skills? But one of the big pieces in the National Mathematics Advisory Panel, we need to increase conceptual understanding. When students have a strong conceptual understanding, they can apply it. And then that's where that flexibility comes in, because they're like, well, wait a minute, 7 times 6, like how many kids freak out? Well, wait a minute, can't I think of 7 as 5 and 2? Well, multiplying by 5 and multiplying by 2 is easy. Okay, so I can kind of break apart 7 and then I can put it back together. But a lot of our students struggle with that. And right away they revert to 7 plus 7 plus 7 plus 7. And then of course their handwriting gets real sloppy and they don't even know what they're adding. And they have like these weird little arrows and it's ineffective because they don't have that conceptual understanding. What do we know about special ed practices? We do know explicit instruction is important. We do know they need examples and non-examples, but then we also are grappling with how do we bring in the math components? And I will tell you, I went from a snapper to a mathematician. I was special ed. I can write a capital D, capital I direct instruction lesson in my sleep. Like I knew the snaps, I knew the symbols. And then all of a sudden I had math reviewers that were like, okay, you gave them the answer. What do you mean you gave them the answer? Like, I'm like, well, yeah, like you start with it and then you ask the question and they're like, so how are you building conceptual? And I'm like, they get the answer. Like, and so really looking at what can I bring in from special ed, but then what can I pair with the math along with those just good instructional practices, those high leverage practices that will lead to that conceptual understanding. I will say a lot of the practices haven't necessarily changed too much, but we really need to think through, yes, the kids need procedural fluency. How do we sometimes build that at the same time as conceptual? There's a lot of research that you have to build the conceptual in order to get procedural fluency. And then the other side and more of the special ed side are like, nope, do the procedure and then we'll teach the conceptual. And what we're finding is that you can do them at the same time, or some kids might need the procedure and then the conceptual. Some kids may need the conceptual and then the procedure. So really thinking through, what does that look like in the classroom? How can I do a little bit of both to increase student understanding and have them be motivated? I think also motivation to even teach math. I was thinking at the elementary where, secondary, you tend to major in math. Like you go in like, I want to teach math. Elementary, you're like, no, I really like the first graders and they're cute and I love reading. And then I have to do math. And they're the ones that are like, I'm not good at math. And they're telling the kids this. And so really thinking through, what does that look like? And then the HLPs, we can't do the HLPs alone and we can't do the evidence-based practices alone. We need to pair those. And so I really try to pull out the key components that are both in math research as well as special ed. I'm going to skip the first one, but that next one, using multiple representations. We know that our students that struggle need to see concrete, pictorial, and abstract. One thing a lot of teachers do is that they often are great with the concrete and then they just jump to the abstract, which is why we have kids that are like, we are playing with these toys and now you're telling me this toy is this problem. And we're not, where's that connection? Where's that bridge? You'll see this in some of the special ed research. Now, this is one that you're not going to see in that true direct instruction. So we're talking capital D, capital I. When you look at explicit instruction, you will see this. And so even talking to teachers when they're trying to identify a good tier 2 intervention, you have to look at, we can have explicit, we can be systematic, we can be scripted, but we still want to see, do we have that concrete representation? Are there pictures? Going back to the first one, working solve problems. This tends to come more from the math research. I love this one, and this is the one I probably push my teachers to use the most because that's what everyone's like, oh, I think this is too hard. The kids aren't going to be able to solve it. Awesome. Don't have them solve it. Let's look at a worked problem. Let's walk through a worked problem. Now let's look at one. Well, wait a minute. They got a different answer. Well, Kim solved it this way. Chinwe solved it this way. Who do you agree with and why? And it's that why piece. It's that justify. It's that evaluate. Those math words that we tend to not teach, but we're not making the kids actually solve it. We're kind of having them look at someone else's work. We're taking that pressure of, hey, don't worry if you don't know the numbers. Let's just work through this together. That middle one, that yellow, the cognitive strategy instruction. That's giving them a little bit of the procedure, but it's helping them understand and organize. You see this a lot with word problem solving. With a first and second grade intervention that we did, we called it Math Scene Investigator. You're a detective. So It is a step-by-step. Every single problem, you read through it, you identify the question, you identify the unit. What are the important numbers? What are the important words? How do you know? And it all gets tied back to the unit. Pirate math is another great one that has that cognitive strategy instruction that allows students to, what kind of problem, how do I attack it? Which then brings us right to the next one, efficient strategies. I like the word efficient because how many of our students are not efficient? In a middle school today, the one teacher was like, why did you go down this hallway? You could have just taken the stairs. And I'm like, the kid wanted to get his steps in. No, students are not tend to be efficient. When you think about younger students, the first time they start solving facts, how many are using all their fingers and they're doing the space tapping and then they're using toes? Like, not efficient. Or 22 plus 13 and they're drawing 22 tally marks, right? We need to teach them efficient strategies so that they're not tripping over themselves. What makes sense? Like that multiplication example way back, 7 times 6. It is not efficient to add 6 7 times. It's more efficient to do 5 times 6, 2 times 6, and then put them back together. And so really thinking through that piece. And some kids are really quick. What happens when it's multi-step? And that's where a lot of our kids that struggle, second, definitely in third grade, it's like, they hit that wall because their inefficient strategies, all of a sudden it's multi-step and they're like, everybody else is on number 4. Okay, I must be done because it's taking them so long to solve that first part that they forget to do the second step and it's just not efficient. And then of course, the motivational strategies. If you look at the practice guides, this is a minimum. But I will say, if you look at some of the research, when kids are involved in their learning, whether it's graphing, whether it's goal setting, having them be part of that. I always think about when we were doing intervention work with first and second grade, most of the kids knew they were struggling in math. And they looked at us like we did some goal setting. They were coming for help. And they like, I'm doing better in class. Except we had some kids, it was while I was at University of Texas, so we called it UT Math. And we had some kids that were very much like, no, I'm doing college level math. That's why I'm being pulled out. I'm like, oh, this poor baby thinks they're doing college level. Like they're lost in class. But really thinking through those strategies, kids try to rush, right? Okay, I'm just going to do it. And I'm not going to think about it. Also thinking through, which is why, again, one-step equations, it's in my head because I was just there this morning. One of them was x minus 9 equals 6. And this kid's like, it's 15. And the teacher's like, okay, but can you show the process? I was like, who cares? Because some of these problems, like I told the kids, I gave the example, I'm like, you all have been doing this since second grade. But instead of a letter, it was a box or it was a question mark. Another example was x plus 3 equals 6. And I'm like, guys, does anyone know this just by thinking about it? Like, where's the thinking? But the teacher was like, nope, they have to minus 3, they have to minus. I'm like, yes, that's the process. But some of these they could just think through. And the student that was like, it's 15. We eventually got him to explain with a lot of questions that, well, I know that 9 plus 6 was 15. I'm like, yes, that's what we want. That's that deeper understanding. I will tell you, my dissertation was in 4th grade, teaching multiplication and division strategies. And I purposely was going in and I did just 1 minute addition, subtraction, multiplication, and division to identify the students. And my goal was I would take students low in multiplication and division, but high in addition and subtraction across the 4th grade. Less than 5 students, not 5%, 5 students were actually proficient in addition and subtraction. And I looked at the teachers and they're like, oh yeah, I mean, I'm not surprised. And I'm like, so what strategies are you using to teach multiplication? All of them go repeated addition. Okay, so how's that working for you if they're not fluent in addition? And when we started teaching the strategies, that's the one thing the teacher said is that they went back to the classroom and started teaching their peers, here's a faster way to solve it. And I'm like, yes, that's what we want. So thinking through all that. And then of course that arrow across the bottom, this is straight from the math research. Discourse is getting kids to talk about it, getting kids to say those answers instead of the teacher explaining all of that. How do we get kids to talk? How do we get kids to create the questions? In most classrooms, it's teacher asks a question, student answers, it goes right back to the teacher. Versus, what if I asked a question, student 1 answered, student 2 added to it, and then it bounced back? Or in the perfect situation, student asks a question, and my only role as a teacher is, can anyone help Melinda? And 2 other people, Jenny says she can help, Brenda says she can help. And I am there just to kind of help facilitate that. That's that classroom discourse. That's where we need to get kids talking. When kids start talking, motivation increases, confidence increases, and their conceptual understanding. It's that whole idea of you can teach it, it's a deeper understanding. And then of course this comes, we have to pair this. We cannot do the high leverage practices by themselves. I always use the example, I could do explicit systematic instruction. I can collaborate. And let's say I'm doing whole language. That's not going to give me the reading scores that I know, like the improvement in reading, because it's not an evidence-based practice. So when we think about those three pieces, how do we tie that or connect it to the high leverage practice? So really thinking through, how do I provide explicit instruction in vocabulary? A lot of kids that struggle in math also struggle in reading, but there's a lot of vocabulary. There's the alphabet in the equation. Forget it. I'm done. Like, I can't read, and now you're telling me I need to solve for a letter? Like, what? And so really thinking through, how are we doing this? An example I use, the word table. At lunch, where do we eat? In the cafeteria, we eat at a table. And then we tell them to fill out a multiplication table, which looks kind of different than the table we eat at. And then sometimes we tell them to draw like a tea table to solve. And then we wonder why kids are confused, and we're like, just use a table. Well, if you have kids that are English language learners, they're like, okay, table. Okay, I eat at one at lunch. So they drawing a rectangle, and you're like, no, that's not what I'm talking about. Like, draw a line. This is the X. Another one we've used as an example, how many times as parents, cut that in half or give the bigger half to your brother. Well, if you're cutting something in half, they should be equal sizes. What rules, what words are we using that expire or lead to a misconception that we then have to undo later on? Barb Dougherty is one of the authors, Karen Carr. The rules that expire, they have one specific for elementary and one specific for middle school. I was working with a great teacher, and she had on her board a resource class. So, lower level class, always subtract from the big number. And I'm like, oh, and every sixth grade teacher is going to hurt you when they have to undo that, because -6 is not bigger than 4. And so really thinking through, how are we teaching our pre-service teachers? Because some of them, we're going to have to undo some of the ways they were taught. And that's what's hard. And that's one thing the research has shown us, is that regardless of teacher certification programs, students often revert to how they were taught. So they need a lot of practice so that they don't walk into, and they're like, that first year deer in the headlights, and they're like, well, I'm just going to go to the procedure. That's what I know comfortably, versus let's try it. And I will say, probably some of the students you're getting now have been part of this new math, have been part of some of that conceptual piece. A couple years ago, we were working 6th to 8th grade. 6th graders were actually doing better than the 8th graders with fractions, because the 8th graders were like the end of the circle kids, meaning they only saw fractions as circles, and the 6th graders had seen the bar model. I don't recommend this. They had an intervention class that was mixed of 6th, 7th, and 8th. A little rough. But the 8th graders were like, well, how can the 6th graders, how do they know to draw the number line with the fractions? And I'm like, they had that practice. Those 8th graders were really the last, like we said, they were the last circle kid with fractions. So they automatically wanted to draw the circle. Yeah, have you ever tried to draw the thirds equally? It's a pain. And as soon as you start talking 8th, 7th, 12th, doesn't work. And so again, trying to make some of those connections. Why do they struggle? Why do teachers struggle? And then this goes back to, why are parents unable to help their kids? Why is this problem challenging? What math vocabulary is needed? And how might you use manipulatives or pictures? The first number in the pattern is 2. After 2, each number in the pattern is determined by the following the same rule: 2, 6, 18, 54. Which of the following rules can be used to determine the number shown after the first number? So this is a NAEP question. I want to say it's from 4th grade. Why is this kind of challenging? It's kind of that misconception, like when we multiply, it always results in larger. Because when we multiply fractions, that's not necessarily the case. And this one, of course, this one has addition and multiplication. So you have the kid that's like, oh, geez, great. Now I can't eliminate any of them because I know that when I add or and I multiply, it's larger. Just the idea of patterns. That's one thing, National Mathematics Advisory. We spend a lot of time in patterns, but they're like triangle, heart, AB, like the kids are like, oh, it's an ABC pattern. Okay, well, let's look at numbers. Numbers have patterns, and the kids are thrown off. If we want to really think about algebra readiness skills, let's talk about patterns as they exist with numbers. What happens when I count by 10? Well, the digit in the tens place. It's not that I'm just going 10, 20, 30. What if I started on 18? Can I count by 10? And thinking through some of those, like let's look at this pattern. Okay, what do we notice? And this is one of those that would be awesome to do as a group. Forget the multiple choice. What do we notice? Someone might say they're all even numbers. Okay, they're all like, they are getting bigger. All right, let's just play. Let's just try to figure this out and have that safe place. I'm sure many of you, if you've been with Cedar, you know these resources exist. But of course, we have innovation configurations. There's 2. One with the partner from Great Teachers and Leaders, the evidence-based math instruction, and then the one through Cedar, innovation configuration. And then of course, the course enhancement module specific to MTSS for math.